In this video, we're going to talk about scale factor for volume. I'm going to try and keep this short, so let's get into it. Okay, we have these two cuboids here, and I'm just going to multiply all the lengths by something. Let's say 1.5. So the scale factor for all the lengths, I'm going to multiply everything by 1.5. So the bottom baseline is 4 centimeters there, so it'd have to be 6 on this one. So 4 times 1.5. Okay, and then the depth would be 3 centimeters, and then the height would be 4.5 centimeters here. Now let's look at what happens to the volume of this particular shape. Okay, so the volume of this cuboid is 4 times 2 times 3. So 4 times 2 times 3. So 4 times 2 is 8, times 3 is 24. So 24 centimeters cubed. That's the volume of that small cuboid. Now let's see what the volume of the large one is. So you have to do 6 times 3 times 4.5. And that is 81 centimeters cubed. Now, what's happened to the volume then? So all the lengths, all the edges were multiplied by 1.5. What's happened to the volume? Well, you could probably guess this for yourself, but it's been multiplied by 1.5 cubed because it's a volume, three-dimensional shape. So 24 times 1.5, I'm just double checking this on the calculator. So 24 times 1.5 cubed, lo and behold, is 81 centimeters cubed, which is the volume of the larger one. So that's kind of like what happens with volume. If you scale all the edges by 1.5, then the volume is multiplied by 1.5 cubed. And just to summarize that, I'm going to do it in a nice little table. So scale factor for length. So for example, if I multiply all the lengths by 3, then the volume gets multiplied by 3 cubed. If I multiply all the lengths by 4.2, then the volume is multiplied by 4.2 cubed. And remember, that's to get from the small one to the big one, so you have to divide to go backwards, obviously. Okay, so if for example the volumes were multiplied by, I don't know, let's say 152 or something, I'm just making that number up. So what would the lengths been multiplied by? Well, they'd been multiplied by the square root of 152, because you kind of go backwards, don't you, really? So that's kind of like how the length and the volumes are connected. So if the lengths are multiplied by 3, then the volume's multiplied by 3 cubed. Or just to summarize this, if all the lengths are multiplied by k, then the volume would be multiplied by k cubed, or scaled by k cubed. And that's how they're connected. Okay, let's do some questions. Let's do a straightforward one. Okay, so we have these two cylinders which are similar, so that I'm telling you that they're similar. Okay, so the length scale factor would be 36 divided by 15, which I think is 2.4. 36 divided by 15 is 2.4. So that is what the volumes were multiplied by. Now remember that 2.4 is to go from the small one to the big one. So the volume of the smaller one would have been multiplied by 2.4 cubed to get the volume of the larger one. So we have the volume of the larger one, so we want to go back to the volume of the smaller one. So we have to take the 5,863 and divide it by 2.4 cubed. Okay, so we're working backwards. Okay, so we know the scale factor for the volume is 2.4 cubed to go from the small one to the big one. So to go backwards, we have to divide by it. So 5,863 divided by 2.4 cubed is roughly 424.117. So let's just put 1. Actually, that's to the nearest whole number. So let's just put 424 centimeters cubed to the nearest whole number. Okay, so just think about how scale factors work. You know, the scale factor we found, if you cube it, that's for the volume, but if you multiply, that takes you from the small one to the big one, and if you divide, that takes you from the big one back to the small one. So that's what we've done here. We've taken the volume of the big shape and divided it by the small one. sorry, divided by the scale factor cube to get the small one. Okay, so that's that particular one done. Again, I hope you understand that. It's a bit. I'm good. Next time around, I'll try and write it a little bit clearly. Okay, this one's a slightly harder question. We've got these two 3D shapes, and they are 3D. Watch this. I can actually spin them around like that. It's cool, isn't it? Really, that's PowerPoint there. So that's the smaller one, and then this is the corresponding similar larger one. Okay, and some information we've got is that the volume of the big one, smaller one, is 264 centimeters cubed. The volume of the larger one is 891 centimeters cubed. We also know the surface area of the larger one, but we don't know the surface area of the smaller one. Now this one's a tough question. Okay, so this is kind of like a summary of the three things we've done. So first of all, what do we do? Okay, so first of all, I'm going to work out the scale factor for the volume. Now, to work out the scale factor for the volume, you take the larger volume and divide it by the smaller volume. So 891 divided by 264 is one hell of a horrible number. It is 3.375. Okay, so that means the volume of the smaller one was multiplied by 3.375. Okay, that's just the number it's multiplied by. Now, let's do a little table for kind of like working out scale factors. So the length, I'm going to put area slash surface area because they're kind of like the same, and then volume. Okay, so the volume was multiplied by 3.375. So what's the length multiplied by? Well, remember how it works. Okay, if you know the length scale factor, that's like k for example, then the volume scale factor would be k cubed, wouldn't it? So this represents a number being cubed. So in order to work out what the lengths are, we need to cube root this number here. If you think about it in a logical way, whatever the lengths were multiplied by, so the lengths were multiplied by some number k, so all these edges here that you see were multiplied by some number k, but then the volume would be multiplied by k cubed, right? But we've just worked out that this is the number that k cubed must represent, so effectively k cubed, the scale factor for the length cubed, is equal to 3.375. So I'm kind of working backwards to work out what this length one was. So I'm going to cube root on the calculator. So cube root of 3.375, that is 1.5. So that means all the edges were multiplied by 1.5. So this edge here, whatever it is, if you multiply by 1.5, that's how long this edge here is. Now, that means the area must have been multiplied by 1.5 squared, because remember how length, area and volume work. If you know this one's squared and this one's cubed. So the area must have been multiplied by 1.5 squared. So in order to work out the surface area of the smaller one, we need to take the surface area of the larger one and divide it by 1.5 squared. So 459 divided by 1.5 squared is 204. So this one must have a surface area of 204 centimeters squared. Now, I hope you kind of understand that particular problem, but if you don't, I'm going to summarize this now in a nice little table. Okay, so these are the scale factors. So scale factor for length, scale factor for area and surface area, and then scale factor for volume. So let's just kind of do it in a summarized form. Okay, if all the lengths were multiplied by k, then the areas would be multiplied by k squared, including surface area. And so if you have like a little shape like this, and if the lengths were multiplied by k, then the area, or in this case would be surface area, would be multiplied by k squared. But then the volume would be multiplied by k cubed. Okay, that's how that works. So if you know the length one, then I'll tell you what, let me write this in a neater way. So if the lengths are multiplied by k, the areas are multiplied by k squared, and the volumes are multiplied by, the volume of the smaller one was multiplied by k cubed. Okay, so for example, if you know that the area has a scale factor of 25, so the length one's got to be 5, right? Because 5 squared is 25. Then 5 cubed is 125. So the volume must have been multiplied. If it was a 3D shape, the volume must have been multiplied by 125. Now, if you know, for example, the volume was multiplied by 27, so then this must be 3, because the cube root of 27 is 3. So the length must have been multiplied by 3. So that means the areas must have been multiplied by 3 squared. Or the area, sorry, I keep saying areas, but I mean area or surface area is multiplied by 3 squared. So for example, if we just pick some random number like, I don't know, 26 or something for the area. So the area or surface area is multiplied by 26. So this would have to be, the length scale factor must be the square root of 26, which is 5.099 blah blah blah. That means the volume scale factor would be that cubed. So that cubed is 132.57. Now remember, these are all the multipliers. That means the length was multiplied by this for the smaller one to get to the big one. The area was multiplied by this, and the volume has been multiplied by this, or that number there, which is its answer. So that's how length, area, and volume are connected. So if the length was multiplied by a, the area was multiplied by a squared, and the area is multiplied by a cubed. And I hope that kind of makes sense. So it's now probably time for you to have a go at some questions related to this as well. So have a look at those caboodle exercises. Tomorrow's lesson we look at some kind of like exam problems related to this and some other problems related to it. And I hope that kind of makes sense. Thank you for watching, guys.